So basically, it depends on which one you're changing to, but we know pi radians is equal to 180 degrees. So if you had degrees and you need to change it into radians, you would multiply by pi over 180. Our common ones, just as a refresh while we're here, 30 degrees is equal to what in radians?
5 or 6.
45 degrees, 60 degrees, and 90 degrees is pi over 2. So those are the common ones. Our trig functions are always continuous as long as you have something in the domain. Remember, sine and cosine are continuous everywhere. The other 4 have asymptotes, so you're continuous between your asymptotes. A couple important formulas. So at the very beginning, I did give you, like in chapter 1, I gave you a formula sheet that had some of the ones we would use. Today we're going to use 2 of these. Sine squared theta plus cosine squared theta is equal to what? 1. Another one that I'm going to use today, just for the purposes of proving something, is our sine sum formula that we had in trig. And we proved why this worked at the time, but it's sine of the first, cosine of the second, plus cosine of the first, sine of the second. So those are 2 trig identities that we are going to use today. One other thing that we know, we saw this back in section 2.2, the limit as theta approaches 0 of sine theta over theta goes to 1, right? And we actually had that as an identity. That's something we know. We don't have to prove that, but this expression still holds true. All right, so let's start off with a limit question. If I want to find the limit as theta approaches 0 of cosine theta minus 1 over theta, can I plug in my 0? No, because I have 0 on the bottom. If I can turn it into sine theta over theta, then I can evaluate. Because although I can't just plug in a 0, we did prove earlier on that that expression was equal to 1. So, any ideas on how I could get there? Only if it's squared. So, what should I multiply by to get a cosine squared?
Oh, cosine of theta plus 1.
Yeah, let's do the conjugate. That gives us the limit. Theta approaches 0. Cosine squared theta minus 1. On the bottom, I'm not going to multiply this out yet. All right. From here, we know cosine squared minus 1. What would that be equal to?
Sine squared. Or sine theta.
So cosine squared minus 1 would have to be negative sine squared. And it comes from this identity. Okay. So what I'm going to do now is separate this. I'm going to leave a negative sine theta. Sine squared, though, is just sine times sine, right? So I'm going to pull one of those signs off. I'm going to leave the cosine theta plus 1 here, and I'm going to pull the theta over to this one. Okay, this is equivalent to what I have here, because if you multiply, you just multiply the top, so we get the same thing. But at this point, we can evaluate the limit. Because on the top, I have the opposite of, what is the sine of 0? Sine of 0, square root of the top over 2 is 0. Over cosine of 0, so square root of the bottom over 2, so radical 4 over 2 is 1 plus 1. This one, I can't do sine 0 over 0, but we know if theta is approaching 0, sine theta over theta goes to 1. And we've proven that before. So then this whole expression turns into 0. Your book kind of sets this off as another identity, something that you can just remember from now on. Sometimes I use it, a lot of times when I have this, I feel like it's one more thing to remember. We can always evaluate it again if we have to, just by multiplying by the conjugate. So you have to at least know that if theta is going to 0, sine theta over theta is equal to 1. This one is kind of bonus. It might save you a couple steps, but if you don't remember this, it won't be the end of the world. You can get it from the other one. All right. I want to now see if we can figure out the derivative of our trig functions. And I'm going to do it by first graphing sine. Okay, so we know sine is 0, 0, 1, 0, 1. So that's what sine looks like. We know how to graph derivatives. Anywhere we have a maximum or minimum, what's my derivative? 0. So here I have a horizontal tangent line, so my derivative is 0. Here I have a horizontal tangent line, so my derivative is 0. This function was increasing. So what does that tell me about my derivative?
It's positive.
It was positive. Okay, this section was all decreasing. So what do we know about our derivative? Negative. This section was all increasing. So my derivative is positive. What does that red one look like? Cosine. So, if all we're going by is the graph, we think the derivative of sine might be cosine. It matches up graphically. Let's see if we can prove it. So if I want to do my definition of derivative, trying to not just give you a rule, but explain the why behind it. If I wanted the derivative of sine, the definition of derivative is the limit as h approaches 0, f of x plus h, so that would be sine of x plus h, minus f of x, so sine of x, all over h. Okay, look back at those trig identities I had you write down for today. If you have the sine of x plus h, the sine sum formula, how do you break it apart?
Sine x, cosine h, cosine x, sine h.
What do you notice about these two? What do they both have in them? Okay, so here's what I'm going to do. I'm going to put those together. Plus this other one. So I'm just kind of breaking apart my fraction. Took the first and last one, put them in a fraction because they have a like term. And I left that third term off by itself. So, if I pulled off this sine x, that leaves me with a cosine h minus 1 over h. Over here, if I pulled off that cosine x, that leaves me with a sine h over h. Now, would I expect you to do this on your own? Absolutely not. But have you followed what I'm doing so far? Strategically rearranging things here. At this point, I think we can do the limit. Sine x, it doesn't have an h in it, so it's still sine x. Times my cosine h minus 1 over h. The limit as h approaches 0 of that expression, look right above this slide, that is equal to 0. Plus, over here, the cosine x would stay since it doesn't have an h in it. Then, what is the limit as h approaches 0 of sine h over h?
Of 1.
You get 0 plus cosine x or cosine x. So, the derivative of sine is cosine. Alright, I'm never going to make you do this proof, but I wanted to explain why it is what it is, not just because I said so. We can use our trig identities and limit laws to get there. So from now on, we know this. Derivative of sine is cosine. So I could work out this problem. If I ask you to do this derivative, I'm going to have to do a product rule because I have two things, they both have an x in them. So product rule is derivative of the first. What's the derivative of x squared?
2.
2x. Times the second. Plus the first. Times the derivative of the second.
Cosine.
And that's it. You can drop the parentheses if you want. 2x sine x plus x squared cosine x. Unlike with polynomials, these derivatives typically get uglier the more that you do, because it doesn't just go away. It gives you another trig function. So all of our previous laws are still true. We've just added to the list. Any questions there? Would you guys like for me to prove the derivative of cosine? If you want to see it, I'll do it. If you don't want to, I won't. It's the same process. You guys want to see it? You're good? You're just going to trust me if I tell you what it is? You would do the same thing. I'm not going to work it all the way out, but you would do your definition limit h approaches 0. Cosine x plus h minus cosine x all over h. And you would have to use the cosine difference formula and strategically regroup there. But the derivative of cosine turns out to be negative sine. All of the cos end up with a negative derivative. So the derivative of sine is cosine. Derivative of cosine is negative sine. You really just have to learn these. Obviously, you could work them out every time, but you don't want to do that. You need to memorize these. You need to know the derivatives of the trig functions. So if I use that, I'll go ahead and show you how to get tangent. We know tangent is the same thing as sine divided by cosine. So the derivative of tangent, if you did a quotient rule, so low d high, what's the derivative of the top? Minus high d low, what's the derivative of cosine? Over low squared. So if we do that, we get cosine squared minus negative, so plus sine squared. Or cosine squared. What's cosine squared plus sine squared? And 1 over cosine squared? It's the reciprocal of cosine. So the derivative of tangent is secant squared. Sine and cosine, you just have to know. The others, you could, if you were on a test or quiz and got confused, you could work them out by doing quotient rule. Probably not the most time effective option, better to learn them. But if you ever got confused, this wasn't too hard to figure out. All right, let's try a problem. So if I wanted to find this derivative, what would we have to do?
Quotient.
So low d high, what is the derivative of the top?
Cosine.
Minus high d low. So derivative of the bottom, you have to go term by term. So the derivative of 1 is 0, plus the derivative of cosine, negative sine. So we just get a negative sine x over low squared. Thoughts? What do you think we need to do here?
Distribute it.
So we get cosine x plus cosine squared x minus a negative, so plus sine squared x. Over 1 plus cosine x squared. Should be starting to feel a little bit like a trig identity at this point. Do you notice anything on the top?
Cosine squared x and sine squared x. So they equals parallel.
Yeah. We have cosine x plus 1 for 1 plus cosine x squared. Cosine x plus 1 is the same as 1 plus cosine x, so I can cancel one of those. Just get 1 over 1 plus cosine x. that okay? Let's try one more. All right. This is a little bit different. We have a cosine cubed. A cube just means you have 3 of them. So to do this derivative, dx dt tells me we're doing the derivative of function x, t is my variable. We're going to have to do the product rule, but it has 3 pieces. So think about what happens in the product rule. You do the derivative of one and everything else stays the same. So that's what we're essentially going to do. We have 3 things. We're going to do the derivative of one at a time. And when we do its derivative, the other 2 stay the same. So, what's the derivative of the first one? When I do that, the other 2 stay the same. Plus. Then we have to do the derivative of the middle one. So the first and the last stay the same. What's the derivative of the middle one? Plus. Now the first 2 stay the same. You're just doing the derivative of the last one. What's the derivative of cosine t? So we can extend the product rule for as many things as we need. You just only do the derivative of one at a time. Now if I multiply these, I get negative sine t cosine squared t in every one of them. And since those are like terms, we can add them all together, and we get any questions so far? I think I'm going to stop here today, and I want you guys to try a few. So we're on day 1. So you have 6 problems to